Alright, we are working some calculus and we're looking at evaluating limits analytically, and we're in this section right here. For those of you who might be watching this somewhere else besides on this website. We got two functions here, and we have the limit as x approaches 23 of f of g of x. Now, instead of doing the regular composite function, actually finding this and then doing the direct substitution where we plug 23 in, there's actually another way of working this, and we're going to discuss a theorem in calculus that covers this. So let's move over to the whiteboard here. Okay, so in the previous problems we hadn't really mentioned anything about any theorems or anything like that, but in this particular one we are. Okay. Alright, so let's get started. So I guess probably what I need to do is write this problem out on the board. 12x minus 3. So we have f of x. Let's just go ahead and get this out of the way. Is 12x minus 3, and then g of x, which I didn't get to look at, is 2x plus 6. 2x plus 6, and we have the limit. I believe that was as x approaches 23 of f composed of g of x. Alright, so what we could do is this is what we could do. We could take this function here, we'd have 12 and then 2x plus 6 and then minus 3, and then simplify all that down. This is f composed of g of x, and then simplify all that down and put it in here and then do the limit. But actually there's another way of doing this. But I'm going to state a theorem. So f and g are both functions, and if we had, and I'm just going to do this generally here, if we had the limit as x approaches, I think we'll call this x approaches c. Okay, yeah, I think that's what I'll call it, of f of x. Or no, let's see, we'll do g here, of g of x, and we'll say that it's equal to L. Okay, and then I'm going to state over here we have the limit as x approaches L of f of x, and that's going to be equal to f of L. You see that? Okay. So if this is true, then we would say that the limit as x approaches c, the limit of x approaches c of f of g of x is equal to f composed of, really is what you'd say here, the limit as x approaches c of g of x, and that's all equal to f of L. Alright, so really what's going on here is we're going to find the limit of g of x, and then we're going to get that answer and just plug it into f, and you know, actually I've already got that worked out right here. So as you can see here, we found the limit of g of x first. We got that number, and then you just take that number and plug it directly in to